In this tutorial, I'm going to be adding some jouissance to my game. Some view model sway and view model bob, as well as some recoil and other VFX, so that we can go from this, pew, 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 to this. Alright, to create the view sway, I already expect that you have a sort of floating 3D arm that is your view model in the game that moves around with the camera. All this one is it's a arm 3D model that I parented to a camera so that it rotates alongside the camera. To create the weapon sway, I created this function called weapon move, and all it takes in is delta. This is just called every frame from func_process, passing the same delta value through. Variables you need is a mouse movement variable to keep track of mouse input, sort of threshold value to say don't actually sway until you've reached this value. You need sway speed to determine how fast your character actually sways. And then a sway amount, which is just how far your character's arm will rotate when you're looking around. And then you also need to keep track of just the default rotation value. I set this right here. Default rot is just equal to the view model's current rotation. This is because my view model is actually rotated around 180 degrees, and I can, if I want to change any of these variables to the default value, then I need to keep that in mind when I rotate it with the sway. The first thing for the sway is I want to keep track of mouse inputs. So I set the mouse movement variable that we declared earlier to a vector3 that has the mouse movement on the y-axis here and the mouse movement on the x-axis here, and then just 0 for the z value. The reason these are flipped is because I just went into the editor and I saw, oh hey, when I move on the, since my model is moved around and flipped, the y-axis is moving it actually on the x, and the x-axis is moving it on the y here. But so you'll just have to look in the editor to determine how you want those to move. The weapon move function, I create a variable called mouse movement length, which is the vector, the input vector dot length. Then I check if that length is less than the negative sway threshold or it is greater than the sway threshold. If it is, then the model should start swaying. To do that, I set the rotation of the view model equal to viewModel.rotation.lerp, and I pass in the mouse movement.normalized, which makes the length of the vector 1, multiplied by the sway amount plus the default rotation. And then I set the speed of the lerp equal to sway speed times delta. To get it to move to the default rotation when we're not moving the mouse, I just added this lerp function here in the else that moves it towards the default rotation. This looks like this in game. When I move my mouse left, I get the arm rotating a little bit to the left, and when I move my mouse to the right, I get it rotating a little bit to the right. Same is true for the up and down, and it just adds a little bit of extra motion, and it makes it look like your character's like actually reacting to your inputs and trying to focus and aim. The view bob is also very similar. We want a start Y value to keep track of what the Y position is at the beginning. Since my view model starts at a negative 0.4 Y value, everything has to be relative to that. Start Y is just initialized in the ready function to the view model's position on the y-axis. Then we have a bob speed, which is how fast we want our arm to be bouncing up and down, and a bob amount, which is how far the thing will move from the starting Y position. I only want my character bobbing if it is on the floor, so I called the character controller and check if it is on the floor. Then I got the time of the game currently running, which is time.getTicks in milliseconds. This returns an integer value, and I converted it to a float because I'm going to be doing some floating point math on it. Then I set the view model position Y to start Y plus the sine function, taking in two parameters, the current time of the game multiplied by the bob speed. And then on the outside of the sine function, I multiply that by the bob amount. And then to take the character's velocity into account, I multiply this by the character controller's velocity magnitude divided by the character controller's max speed. This calculates how fast the character is moving relative to their maximum speed. Then when I run the game, you can see that the character's arm moves up and down as I'm moving forward and backwards. If I start bunny hopping in this game, which I have implemented, you can see it becomes a little bit weird because it will jitter when I'm up in the air, but it doesn't look so bad for normal use. I need to figure out like a way to make the more natural in the air. If you have any suggestions for that, leave it in the comments. Then I wanted to add recoil to my character, so I took the view model's rotation on the X and did a minus equals with a staff recoil. The staff is just the weapon I'm currently holding, and the recoil is a parameter I added to it so that I can create different recoil amounts for each gun. Because it rotates the view model, this code down here will reset it to the default rotation, so I don't have to worry about that. It just reuses the same code. That looks like this in game. Pow, 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 pow. To add a particle effect to my staff, I followed along with this Godot VFX tutorial by Gabriel Aguiar, and I just added the sparks particle and the bright flash particle. I modified them a little bit to fit make them more wizardly and less fire-like. Then I added 2 sound effects, one sound effect for when the particle is fired, and then one sound effect for when it hits an object. Finally, I added an impact decal so that you can tell where the projectile landed. It just is the decal object in Godot, and I set like a little burn texture here. Now, when I fire a projectile, it's super cool and very swag. Boom, boom, yeah. As you can tell, the decal looks a little bit strange on the wall. I need to rotate it to face towards where it landed.